It's a bit of a paradox. Professor Cumrun Vafa of the Havard University says that our universe may not exist. And Vafa, one of the leading representatives of the string theory, thinks that we could find clues for the theory through this approach. This would be an absolute breakthrough, and it would also fundamentally change our understanding of space and time and 6 to 7 other dimensions. Welcome to Clixoom Science Fiction.
1, 2, 3.
If evidence for the string theory would be found, it would completely change our view on the world. This unproven hypothesis states that not particles are the smallest units in our universe, but strings, much smaller threads that, depending on how they vibrate, make different particles appear: quarks, bosons or leptons. However, as scientists calculated these threads, they came across something unbelievable. These strings do not exist in space and time, but in many more dimensions, namely 10 to 11. But where are these dimensions? Why can't we find them, learn about them? This hypothesis has an answer for that too. They are folded together within very small space, almost crumpled up. In the course of their calculations, the researchers then found that universes upon universes could exist on this basis. And this is where Cumrun Vafa is now stuck. Many of these universes cannot actually exist. And our universe is one of them, at least as we have defined it so far. For example, in an existing universe, gravity has to be much weaker than all other forces. That's correct in this case. Gravitational waves, as a result, are very weak and hard to find. But according to his calculations, one thing does not work: a universe with 70% of dark energy, as we assume here. According to Vafa, a universe like this is impossible. Dark energy is so far theoretically predicted energy that causes our universe to drift apart faster and faster. While we can still see many neighboring galaxies today, this will no longer be the case in the distant future. They are too far away to see them. 70% of what exists is said to be that energy in our universe. But Vafa has calculated something else, and that really contradicts a lot of things. According to his calculations, for an existing universe based on string theory, this energy must not have a fixed value, but it must change. In other words, from our point of view, in a closed system such as our universe, content changes. That's crazy. But for physics, the value of the dark energy is also crazy. According to calculations, it would be much more natural if dark energy were 1,000 times stronger than it is. But up until now, it was assumed that it has an impossible fixed value, according to Vafa. But whatever. Some things don't seem to be right here. And this is where Vafa could help, because he calculated how the dark energy would need to change if the string theory was applied. And that is extremely slow but measurable. In other words, measuring a change in the dark energy would be a strong indicator that string theory is actually true. That would turn everything upside down. At CERN, they would have to build a much larger particle accelerator to find the strings, and we would live in a very strange 10 to 11 dimensional universe. As part of the Dark Energy Survey, a 3-dimensional map of the dark energy is created right now. Additionally, the space telescopes WFIRST and Euclid will be watching the dark energy more precisely in the future. The results could be revolutionary. Continue here with our video on the end of the universe. And if you don't want to miss a video on this and all the other topics, then subscribe to Clixoom. Do not forget the bell. Until next time, stay tuned and see you soon.